those who are speaking in this session should hang around so we can ask y'all some questions. But I would like to start off with actually a question for Jim in terms of the differentiation and how we might expect that with the crystal settling to scale to smaller basins or even to scale upwards to SBA. What would your thoughts be in terms of what we would expect in terms of the different sizes of basins?
So I think basically this is partly outlined in Will Vaughn's and Deborah's papers as well in detail, actually, some detailed predictions. But the bottom line is, it's as you increase in size, you're going to change the characteristics of the substrate you're excavating down to lower crust and to mantle. So that's going to have a huge input onto, you know, what ultimately happens. In terms of the cooling times, we were, you know, we did some preliminary calculations looking at Copernicus, and based on the modeling, it looks like the effect of the rapid cooling and the rapid convection is close to similar for the grain size function for something of the order of Copernicus, which is 96 kilometers about in diameter, and Oriental. So it looks like that the rapid cooling may be a big factor across the spectrum of those sizes, and therefore it would inhibit the essentially differentiation.
Follow up. What about if there were a very large impact on a small on an asteroid or on Phobos or Deimos that would be large enough to create a basin? You've clearly got different degrees of cooling. It's a different size body. So what would you expect for that?
Absolutely. There's a lot of factors involved So for example, there's evidence for terrestrial impact craters that there is some differentiation going on. And you know that there's a lot of additional factors there. So like on an asteroid, if it was like Ceres versus Vesta, you know, there'd be huge differences based on the volatile content of the substrate, for example. And that is potentially why we may see things on the Earth that are a little different than what we predict. You know, the effects of just simply the water content is going to have a huge effect. So yeah, it's not simply scalable, just conceptual. You have to take all those other things into consideration.
You've got to have some sort of sporting ability to work with this thing. So I'm just interested in, that was basically going to be my next question, actually, because in terrestrial melt sheets, we do have some constraints based on the geochronology. I think for Sudbury, it looks like zircons maybe span about 500,000 years in the Sudbury melt sheet, and that's, I think, 2 kilometers thick. So it would be interesting to dig into that, dig into the physics of it.
So if these calculations are correct, it could be one of two things. Either that you realize how close that was? If you could just kick it, it would be okay. Hello? The computer was saying that's the important thing. And that's what he learned at rugby, was to stay clear. Ricky, I'm sorry. Broke it? Killed it. That's what happens when you throw it in the southern hemisphere. Sorry about that. Is it not? It's not dead, is it? Totally. Okay. Jesus, what was the question? Okay, so yeah. So okay. So yeah. So in those cases, you know, clearly something different is going on. So maybe it's a grain size effect. You know, that's another thing. So grain size versus the role of water and other factors there might make it differently. Or our calculations are wrong for some reason. You know, that's another.
It's just interesting. Yeah, I mean, there's potential, like you say, there might be really such a freeze.
Yeah, I think the exciting part is that at least these treatments outline options, okay, and reasons for the differences. So, you know, when we go in and look at in more detail at moon mineralogy mapper data and other data for the three-dimensional structure of these things, you know, it will have a kind of like a menu to be able to kind of like choose from, and hopefully that'll help narrow down some of the options.
I just wanted to follow up on one of the questions that was asked about the size of the Orientali impactor, I think. Sorry. So yes, there was an earlier question about the size of the Orientali impactor. And so I've done some modeling of the formation of the basin, and my calculations suggested the impact would be between 50 and 80 kilometers in diameter. The size of the impactor would be slightly dependent on the thermal state of the target. As I mentioned before, that has some effect on what kind of crustal structure you will form afterwards. So in a colder structure, you would need a larger impactor, whereas in a warmer structure, you'd need a slightly smaller impactor to form Orientali. And in the modeling itself, we normally use a Dunite equation of straight to represent the impactor, because that's the most commonly used in the models, and it's a good representation of sort of the average composition and density of asteroids.
Ricky said it was just the battery, so we didn't kill it. Are there any other comments or discussion questions? So this is your last chance for the meeting, guys. There's got to be something that's just really burning question. No? All right, well, if there's nothing else, then we'll take a short break before everyone reconvenes in here.